So here we have a 1.5 times 10 to the third kilogram car starts from rest. It accelerates uniformly to 18 meters per second in a time of 12 seconds. It's just assumed that air resistance remains constant at 400 Newton during this time. So for this particular problem, there is air drag that we have to account for. So part A wants us to find the average power developed by the engine, and then part B wants us to find the instantaneous power output of the engine at exactly 12 seconds. Okay. All right. So let's do this. First, for part A, I do like to point out as you practice power, it's important to pay attention to what the question wants. In this part A, it wants us to find the average power developed by the engine. All right, so keep in mind that this particular problem has air drag thrown in there. So to find the average power by the engine, we need to find the work done by the engine divided by time. Well, to find the work done by the engine, you need the force of the engine times the displacement. So we know the car is going to be going rightward in this case. So here I've highlighted two things that we don't know. We don't know what the F of the engine is, and we don't know what the displacement is. We know what time is. Time is 12 seconds, which is given in the problem. So I'm going to go ahead and find F engine and delta X, and then once we find those two pieces of information, we're pretty much done with power here. Okay. So in terms of free body diagram, we know that the engine is going to be exerting, some sort of force here to cause the car to accelerate to the right. So this is F engine, but at the same time, this problem said that there is a constant 400 newtons of air drag. Okay, so I'm just going to call this F drag. So here, the engine is going to cause the car to go to the right. At the same time, there's air resistance, so it points against the motion, which is pointing leftward. So I'm just going to apply Newton's second law. Newton's second law says that the net force is equal to ma. Well, I know that there are two forces in the horizontal direction for this one. There's F engine, which is generating the power, and then there's F drag, which is acting against the car's motion. So I'm just going to say F engine minus F drag, because F drag is acting against it, so it has to be minus, equals ma. Okay. Well, I can go ahead and isolate for F engine by moving this negative F drag to the right side of the function. Okay, so F engine equals to ma plus F drag. So the negative sign changes sign when you move to the other side of the equal sign. And then here you notice you have m. M is 1,500 kilograms, which is the same thing as the scientific notation here. A, I highlighted because I don't know what A is. F drag, I do know because it says F drag is a constant 400 newtons. So the only thing I'm missing here is A. So therefore I need to find A. Well, to find A, I can just use the information given to me. It's just that the car accelerates from rest to a speed of 18 meters per second here in a time of 12 seconds. So you have your change in velocity, you have your change in time. So to find A, you just simply do change in velocity divided by change in time. So here, my final velocity is going to be 18 meters per second. My initial is 0 meters per second divided by the time interval, which is 12 seconds for this problem. And that'll give me an acceleration of 1.5 meters per second square. So I know what A is. Now I can just go ahead and finish this particular statement. I can find F engine now. So I can plug in mass is 1,500 kilograms. A, I just found is 1.5 meters per second square. I'm going to add the 400 that's given to me. Okay. All right. So if you do your math correctly, you should get a value of 2,650 newtons. So the engine is outputting this much force, 2,650 newtons. But it's not getting all of that because there's air drag involved here. So I know what F engine is. The only other thing that I got to find is delta X, my displacement. How far did the car travel during this 12 seconds? Okay, so for this one, I do a little different. If you know your kinematics, because A is a constant, I can just use my two average velocity function and set them equal to each other. So here I can just say that the displacement is the final velocity plus the initial divided by 2 times the time interval. Well, the initial velocity here is 0. My VF is 18 because it's given to us. 2 is part of the function, and then t here is 12 seconds. So I'm just going to do a little plug and chug. VF is 18. 2 is part of the function. Delta t here is 12 seconds. So if you simplify it in your calculator, you should get about 108 meters. So I just found F and I just found delta X. Now I have everything. So I'm just going to go ahead and go back to the left side of the screen here. F engine, I'm going to substitute it for 2,650 newtons. My displacement is 108. F engine is pointing right, and then also here the displacement is pointing right. Anyways, power is a scalar, so you're good here. 12 seconds is given, so simplify that. The numerator should give you 286,000, and 200 joules divided by 12 seconds. And if you further simplify that, you should get a value of 23,850 watts. Okay, once again, the unit for power is watts. Sometimes it is measured in kilowatts. If it does that, all you have to do is convert watts to kilowatts. All right. Other than that, that is it for part A. So the answer is 23,850 watts. Now let's do part B. Okay. Part B wants us to find the instantaneous power output of the engine at 12 seconds. Well, the statement here is a little different. You notice here in part B, it didn't want the average power. It wants the instantaneous. How much is the car outputting at that exact moment? Okay. So to find instantaneous power, all we have to do is just use the F at that particular time times the velocity at that particular time. So the engine here is exerting a constant force that we just calculated in part A. V of t is at 12 seconds because it says the instantaneous power at 12 seconds. So light work. So to find the instantaneous power exerted by the engine at exactly 12 seconds, I need to know what the force is at that moment. Well, the force at that moment is the same because it exerts a constant force of 2,650 newtons. This is the force by the engine. Well, what is the velocity at that moment in time? Well, at 12 seconds, the problem states that it is moving at a rate of 18 meters per second. And the wording here says so. It says uniformly to 18 meters per second in 12 seconds. So this particular part references 12 seconds. So my final velocity or my instantaneous velocity would be 18 meters per second. So therefore, the instantaneous power, would be 47,700 watts. Okay, and that's it for part B. The trick is to make sure that you, one, use the correct force, whatever force the engine is outputting at that moment, and then whatever the velocity is at that moment in time. All right, so differentiate between average and instantaneous. All right, stay nerdy, don't be whack.